Hello everyone, welcome to the channel Amazing Civil Engineering Studies.
Hello friends, in this video we will study about
beams and columns. Definition, types, loads. What are beams and columns in structural engineering? The system of columns and beams have been used in so many ancient civilizations such as ancient Egypt, 3100 BC, and the Roman Empire, 30 BC, ancient Greece and ancient Rome. Nowadays, slab beam column system is used widely in all superstructures with modern technology and materials for the construction process. Generally, the load of the slab is directly transferred to the beams and then to the columns, down to the foundation, and then to the supporting soil beneath. First we will discuss beams. Beams. Beams are horizontal structural elements responsible for transferring loads from the slab, dead and live loads, to the columns. We determine the dimensions of the beams according to the value of the internal forces, moment shear normal, located on them. Beams are divided into two main types, steel and concrete beams, and they are used for so many purposes such as beams under the walls carry the wall over them to avoid being loaded directly into the weak concrete slab. Beams are used to tightening the columns to provide better distribution to the bending moment in the beams as well as to reduce the length of the bending of the columns. Beams concrete slabs of large areas shall be divided into parts, each with an area that can be designed to be thick and economically reinforcing. What is beam? The beam is a structural element that stands against the bending. Mainly beam carries vertical gravitational forces, but also pull the horizontal loads on it. The beam is called a wall plate or sill plate that carries the transmits and load it to the girders, columns, or walls. It is attached with. In the early centuries, timbers were the most preferred material to be used as a beam for this structural support purpose, now to bear the force along with carrying vertical gravitational force. Now they are made up of aluminum, steel, or other such materials. In actual means, beams are these structural materials, which bear the shear force of the load and the bending moment. To carry on the more tension and load, pre-stressed concrete beams are widely used nowadays in the foundation of bridges and other such humongous structures. Several famous beams used nowadays are supported beam, fixed beam, cantilever beam, continuous beam, overhanging beam. Types of beams. Types of beams in constructions. There are different types of beams which are classified based on the following conditions. Based on support conditions. Based on construction materials. Based on cross-section shapes. Based on geometry. Based on equilibrium condition. Based on method of construction. Others. Based on support conditions. Simply supported beam. It is one of the simplest structural elements that both ends rest on supports but is free to rotate. It contains pin support at one end and ailer support at the other end. Based on the assigned load, it sustains shearing and bending. Fixed beam. It is supported at both ends and fixed to resist rotation. It is also called a built-in beam. The fixed ends produce moments other than the reactions. Cantilever beam. If a beam is fixed at one end and set to be free at the other end, it is termed as a cantilever beam. The beam distributes the load back to the support where it is forced against a moment and shear stress. Cantilever beams allow the creation of abattis window, balconies, and some bridges. Continuous beam. A continuous beam has more than two supports distributed along its entire length. Based on construction materials. Reinforced concrete beams. It is constructed from concrete and reinforcement as shown in Fig. 5. Sometimes reinforced concrete beam is concealed in reinforced concrete slabs and it is called hidden beam or concealed beam. Steel beams. It is constructed from steels and used in several applications. Timber beams. The timber beam is constructed from timber and used in the past. However, the application of such a beam in the construction industry is significantly declined now. Composite beams. Composite beams are constructed from two or more different types of materials, such as steel and concrete. Figure shows different valid cross-sections for the composite beam. Based on cross-section shapes. Several cross-sectional shapes of beams are available and used in different parts of structures. These beams can be constructed from reinforced concrete, steel, or composite materials. Reinforced concrete cross-sectional shapes include rectangular beam. This type of beam is widely used in the construction of reinforced concrete buildings and other structures. T-section beam. This type of beam is mostly constructed monolithically with a reinforced concrete slab. Sometimes, isolated T-beam is built to increase the compression strength of concrete. Added to that, inverted T-beam can also be constructed according to the requirements of loading imposed. L-section beam. This type of beam is constructed monolithically with a reinforced concrete slab at the perimeter of the structure. Steel cross-sectional shapes include. There are various steel beam cross-sectional shapes. Each cross-sectional shape offers superior advantages in a given condition compared with other shapes. Square, rectangular, circular, I-shaped, T-shaped, H-shaped, C-shaped, and tubular are examples of beam cross-sectional shapes constructed from steel. Based on geometry. Beam with a straight profile, and the majority of beams and structures are straight beams. Curved beam. Beam with curved profile, such as in the case of circular buildings. Tapered beam. Beam with tapered cross-section. Based on equilibrium condition. Statically determinate beam. For a statically determinate beam, equilibrium conditions alone can be used to solve reactions. The number of unknown reactions is equal to the number of equations. Statically indeterminate beam. For a statically indeterminate beam, equilibrium conditions are not enough to solve reactions. So, the analysis of this type of beam is more complicated than that of statically determinate beams. Based on method of construction. Cast in situ concrete beam. This type of beam is constructed on the project site. So, forms are initially fixed, then fresh concrete is poured and allowed to harden. Then, loads would be imposed. Precast concrete beam. This type of beam is manufactured in factories. So, the construction condition is more controllable compared with on-site construction. Consequently, the quality of the concrete of the beam would be greater. Various cross-sectional shapes can be manufactured, such as T-beam, double T-beam, inverted T-beam, and many more. Pre-stressed concrete beam. The pre-stressed concrete beam is constructed by stressing strands before applying loads on the beam. Pre-tensioned concrete beam and post-tensioned concrete beams are variations of pre-stressed concrete beam. Other beams. Deep beam. A deep beam has considerable depth, as shown in figure, and its clear span to depth ratio is less than 4, as per ACI code. A substantial load is carried to the supports by a compression force combining the load and the reaction. Consequently, the strain distribution is no longer considered linear, as in the case of conventional beams. Girder. Beams that take heavy loads, generally steel sections are used. Types of loads on beams. Self-weight of the beam. Dead load includes point load, for instance column constructed on beam, distributed load, for example setting slabs on a beam. Live load. Torsional load. Load transfer mechanism in beams. They transfer loads imposed along their length to their endpoints, where the loads are transferred to columns or any other supporting structural elements. Columns. What is column? A compression member, i.e., column, is an important element of every reinforced concrete structure. These are used to transfer a load of superstructure to the foundation safely. Mainly columns, struts, and pedestals are used as compression members in buildings, bridges, supporting systems of tanks, factories, and many more such structures. A column is defined as a vertical compression member who is mainly subjected to the effective length and axial loads of which exceeds 3 times its least lateral dimension. The compression member whose effective length is less than 3 times its least lateral dimension is called pedestal. The compression member who is inclined or horizontal and is subjected to axial loads is called strut. Struts are used in trusses. The function of columns is to transfer the load of the structure vertically downwards to transfer it to a foundation. Apart from the wall, performs the following functions also. It encloses building areas into different compartments and provides privacy. It provides safety from burglary and insects. It keeps the building warm and cools in summer and winter. Types of columns in building construction. There are several types of columns which are used in different parts of structures. Column is a vertical structural member that carry loads mainly in compression. It might transfer loads from a ceiling, floor slab, roof slab, or from a beam, to a floor or foundations. Commonly, columns also carry bending moments about one or both of the cross-section axes. In this article, different types of columns used in building construction will be discussed. Types of columns in building construction. Columns are classified based on the several conditions which include: based on types of reinforcement, based on types of loading, based on slenderness ratio, based on shape, based on construction material, based on types of reinforcement. Tied column. This type of column is commonly construction from reinforced concrete. Longitudinal. Reinforcement are confined within closely spaced tie reinforcement. It is estimated that 95% of all columns in buildings are tied. Spiral column. Spiral column is also construction from reinforced concrete. In this type of column, longitudinal bars are confined within closely spaced and continuously wound spiral reinforcement. Spiral reinforcement provide lateral restraints, Poisson's effect, and delays axial load failure. Ductile. Composite column. When the longitudinal reinforcement is in the form of structural steel section or pipe with or without longitudinal bars, it is called as a composite column. This type of column have high strength with fairly small cross-section, in addition to exhibit good fire performance. Based on types of loading. Axially loaded column. If vertical axial loads act on the center of gravity of the cross-section of the column, then it is termed as axially loaded column. Axially loaded column is rare in construction since coinciding vertical loads on the center of gravity of column cross-section is not practical. Interior column of multi-story buildings with symmetrical loads from floor slabs from all sides is an example of this type of column. Column with uniaxial eccentric loading. When vertical loads do not coincide with center of gravity of column cross-section, but rather act eccentrically either on x or y axis of the column cross-section, then it is called uniaxially eccentric loading column. Column with uniaxial loading are generally encountered in the case of columns rigidly connected beam from one side only, such as edge columns. Column with biaxial eccentric loading. When vertical on the column is not coincide with center of gravity of column cross-section and does not act on either axis, x and y axis, then the column is called biaxially eccentric loaded column. Columns with biaxial loading is common in corner columns with beams rigidly connected at right angles at the top of columns. Based on slenderness ratio. Based on slenderness ratio, effective length/least lateral dimension, columns are categorized as follow. Short column. If the ratio effective length of the column to the least lateral dimension is less than 12, the column is called as the short column. A short column fails by crushing, pure compression failure. Long column. If the ratio effective length of the column to the least lateral dimension exceeds 12, it is called as long column. A long column fails by bending or buckling. Based on shape. Shape of reinforced concrete column. Square or rectangular column. They are generally used in the construction of buildings. It is much easier to construct and cast rectangular or square columns than circular ones because of ease of shuttering and to support it from collapsing due to pressure while the concrete is still in flowable form. Circular column. They are specially designed columns, which are mostly used in piling and elevation of the buildings. L-shaped column. Commonly, L-shaped column is utilized in the corners of the boundary wall and has similar characteristics of a rectangular or square column. T-shaped column. It is utilized based on design requirements of a structure. T-shaped column is widely used in the construction of bridges. Shape of steel column. There are different standard and built-up shape of steel columns which are shown in Fig. and Fig. Common shapes of steel columns include I, channel, equal angle, and T-shape. Shape of composite column. The usual shape of composite columns are shown in Fig. Based on construction material. Types of columns based on construction materials include reinforced concrete, steel, timber, brick, block, and stone column. Types of loads on columns. Self-weight of the column multiplies by number of floors. Self-weight of beams per running meter. Load of walls per running meter. Total load of slab, dead load and live load and self-weight. Loads transfer mechanism in column. Since the columns are supported by foundation, the load relocated from the all components to the columns. Then, it will be transferred from the column through the column necks adjacent to the footing in the form of axial force. Moreover, columns transfer lateral loads to foundations as well when such loads imposed. Lastly, it will transfer moment and shear also to the footing. Load transfer mechanism from column to footing. Difference between beam and column. No. Beam. Column. 1. Communally, a horizontal member of a structure that resists transverse load is called beam. Communally, a vertical member of a structure that resists axial eccentric load is called column. 2 BEAM is carries load perpendicular to longitudinal axis. Column is carries load parallel to longitudinal axis. 3 BEAM is basically carries or resists bending and shear force. Column is basically carries or resists compression load. 4 BEAM's shape can be square, rectangular, T-shape, I-shape, H-shape. Column shape can be rectangular, circular, square, T-shape, L-shape, C-shape, elliptical, etc. 5 Minimum width of beam is 200 mm. Minimum width of column is 200 mm, however for earthquake resistance it should be 300 mm. No. Beam. Column. 6. Longitudinal steel in beam is on two faces, which is used to resist bending moment, while the vertical loads are resisted by stirrups or inclined beam. Longitudinal steel in column is on all faces, which basically resists compression. 7. Communally casted with slab, and hence greater care is observed for its concreting and curing in case of RCC structures. Communally casted in small batches, and hence quality of concreting as well as curing ignored in case of RCC structures. 8 BEAM without building possible. Here, column important part of building.
Thank you for watching.
For now, please subscribe, like, share and do not forget to press bell icon.